Hi everyone, welcome back to the Microsoft series. So in case if you have not registered yourself for the Microsoft in 29 days self-paced course, so I'll request you to register for this course, and after you register for this course and click on the start course button, so you'll be redirected to this website where, let's say if I'm talking about let's say day 2, so I can go to day 2, and what I can see here is I can see that I'll be having the individual video recordings of each and every problem that I have solved, and then you will get access to the problems here, right? You can see count distinct elements, then array, pair, and things like that. So you'll get a lot of benefit from this course, like total one almost 150 problems that we discussed. But you for that you have to register for this as well, and you can also see yourself, track yourself on the leaderboard along with the other peers as well. Thank you. Now let us move to this problem, that is permutations of a given string. So the problem says that they will give me a string, like I'll be given a string, and I have to. The task is to print all the permutations of the string in lexicographical order. So let us say that if the string given to me is AB, okay. So if the string is AB, then what will happen? Like one of the permutations will be AB, another permutation will be BA, right? That will be the case. But suppose that a string has been given like A, B, C. So in that case, one of the permutations will be ABC, then another permutation will be ACB. Okay, so you can see that I have kept A as fixed and then swapped C and D, right? Then what another permutation could be, what I swap B and A, so BA and then C. Okay, then what I do is B, then CA. After that, another permutation could be what, like it could be C, B and A, then it would be what, it would be C, A and B. So this will be the 8 different permutations for it. So like if I have ABCD as well, so I'll have permutations for it as well. So what are the total number of permutations actually? The total number of permutations will be factorial in nature, as you can observe, because the permutations are going to be a lot. So how can we do it? So to try out this, first of all, basically if you see the number of permutations, if I tell you that okay 1 2 3 is there and what is the total number of permutations, so you'll see that for this character, like if I take ABC only, right, if I take, let's say AB, if I take AB only, right, so you will say that for this character there are, for this position, like if I take two positions, for this position you will say that two choices, and for this position you will say that one choice is there, right? So total n factorial choices are there. Similarly, if I talk about ABC, right, if I talk about ABC, right, if I talk about ABC, so there are three positions. So for this position, three choices. For this position, two choices. For this position, one choices. So total three factorial will be the answer. If I give you ABCD, then the answer would be nothing but n factorial, right? That is nothing but 4 factorial here. So will you try and make every permutation? No, it will take a lot of time. So if we are doing some task repetitively, then I can think of doing one thing, and that is nothing but recursion. Because if you see, what I did was I had ABC and I generated ACB as well, right? So I swapped something I did. Then I can say, like, first of all I tried to fix A. Then at the first position I tried to fix B, and then I made what? Then I made this thing BAC and BCA. So what can we do here? So I'll tell you. Basically, what we can observe here is that the one thing that we can observe here is that, like, let's suppose we have the string like A, B, C. So what we will have is, let's say we have an index, okay? We currently have an index like pointing to this, okay? And then what I'll say is that currently you fix this index, okay? You fix this index. So basically what you do is you start your movement of I from the next character, okay? From, like, you say that, like, maybe you can say that you start from this index only. You start your I from this, and you do what, every time what you do is you swap s of I with s of index, okay? Every time we will try to swap s of I with s of index. So what happens when I swap A and A, okay? What will happen when I swap A and A? So when I swap A and A, then the string is still A, B and C, okay? The string is still A, B and C. Now you will observe, suppose that that my I moves to this, right? Suppose that my I moves to B, then in that case if I swap, so what will happen? In that case, the new string will be what? The new string will be nothing but A, and if A and B are getting swapped, then it will be what? It will be B, A and C. Suppose what happens after that? Suppose my index is still standing at A, okay? And now I swap again. So now I'll swap, like, my I moves to this index, so I will swap what? I will swap A and C here, right? So basically this will be C, B and then A, right? This will be the case. Now what happens here is, now my index will be moving, right? So index has moved here, like index, this variable index int has moved here, int has moved here, int has moved here, and then I'll start my I from this position only. And now I will say what? Suppose that I swap B and B, okay? When I, like, index is standing here, and when B is, like, I is also standing here. If I swap B and B, then what will I get? I will get nothing but A, B and C only. But suppose my I moves to this and my index is still standing at B. So like in at this level I have basically done index plus 1, right? So if I do this, right? So here what will happen? Here it will be A, then C and then B, right? This will be the case. Similarly here if I see, so if my I index is standing here and I is also standing here, so I swap A and A, so what do I get? I get nothing but B, A, C only. And suppose that I do what? I moves to C, like if I moves to, if I keeps pointing to C, then it will be B, C, A, right? Similarly here as well, like when my index is pointing to B, then I have started a loop from index only. So what will happen in this case? In this case you will observe that first of all I swap B and B, okay, here what did I swap? Here I swap nothing but C and A, right? So like here if I swap B and B, so this will be CBA. Okay, now if I swap B and A, right? If I swap B and A, then it will be what? CAB. Nah, right? So now you can easily observe. Now you can easily observe. I have done what? I have done index plus 1. Okay, now my index will stand here, and index will stand here, index will stand here, index will stand here. So now you can see that if even if I swap, then it will not affect, right? After that, when I do index plus 1, so whenever like it will be the new index, so I can see that I have exhausted the length, right? Initially here the length was 0, here the index value was what? Here the index value at the next level was 1, then at this level, then at the next level index value was 2. Then after that, when I moved to the next level, which is not existing, so index value became 3. Then I stopped. So when did I stop? When index became 3. So when index become equal to the size of the string that has been given, then I stopped. And the moment I stopped, so I can see that I am finding all the strings, right? You can see ABC is there, then ACB is there, right? Then another thing BAC is there, BCA is there, CBA and CAB. Now since I want to print this in sorted order, so maybe what I'm thinking of is I can store it in a set, because what will happen if I store it directly, then this BA like CBA and CAB will not be in ascending order, it will not be in sorted order, right? It will not be in lexicographically smallest order. So that's why I can keep it inside a set so that I can store it, right? This will be the case. So let us try and develop a little bit of logic on this part, and then we'll be seeing further what we can do here. So basically what I will be having is, I'll be first of all having a set of the strings, okay? So set of a string, and then I'll mark it as, let's say, st. Okay, after this part is done, so what am I going to do? I'll declare, let's say, a recursive function. Okay, in this recursive function, what I will be doing is, in this recursive function, first of all I'll pass the index as 0, then I'll pass the string s, right, as capital S, and another thing I'll pass is the set st. Okay, so after this I'll see what I will be doing further. Okay, so maybe what I can say is that since I want to store the final answer in a vector of strings, I want to return in a vector of strings, so I'll have an answer, and in that what I will be doing is I'll be like whatever I get in the set after the iterations are done. So I will say that set dot begin, whatever is there inside the set after I have stored all the permutations of the string, that I'll be storing inside the answer vector, and I can say that I'll be simply returning this answer, right? That is the vector that contains all the string permutations in sorted order, in lexicographical order. Now what I will be doing here is I will say that I'll have a void recursive function for myself, and in this function what I'll be having is I'll be having the index as I mentioned. Okay, I'll be having the index, and I'll be having the string s, right? I'll be having the string s. Apart from the string, another thing that I'll be having is I'll be having the set, right? So set of what? Set of a string, and then like ampersand st, right? This is what I will be having. And what is the base case of this recursive function? If the s dot size, right, if the size of the string becomes equal to the index, right? If so, basically you can say that if the index becomes the size of the string, so if it's equal to the s dot size, if it's equal to the size of the string, then I can say that I can store the current string that is there, and then I can simply move back. I can backtrack. I can move back from here, right? Because the moment like I hit this thing, so I can simply store ABC and then I can move back, right? This is what I'll be doing. So I'll say that what I'll be doing is I'll say that st dot push, nothing but what, st dot push is I'll say that I need to push what, I need to push the current string s inside the set, and I'll simply return from this recursive call. Otherwise what I'll be doing is I'll be iterating as I said. So int I starts from in the index that I am starting at, I is lesser than the size of the string, and then I do an I plus plus one by one. And what am I doing? I am saying that you do what, you do a swap function. Since we'll be doing in recursive manner, so what I swap s of the index, right, the current character, the current whatever character is there at the index, I swap it with S of I, right? I swap. So initially, as I mentioned, I'll swap A with A, then I'll swap what? I'll swap A with B, then I'll swap A with C. Like that, I'll be doing on. Okay, and then like as I mentioned, right? Since this is a recursive call, so what will I do? If I after I have swapped this, right? So suppose after swapping, I'm at this state that is BAC, right? If I'm at this state BAC, then what will happen? I'll move to the next index, right? After this part has been swapped. So suppose after swapping I reach here. So after I am at BAC, so I will move my index to the next character. So I'll say that index plus one. So I'll call this function recursively for the index plus one part. And what I will say is that I'll pass the string and I'll pass the set st as well. Now, is there anything else that I need to do? Yes, there is one more thing that I need to do. Like if you see here, so actually this is now not like the recursion is not level order, right? It's not built like horizontally, right? First of all, you go into the depth, right? You go into the depth. So initially you will store ABC, that will be fine. But suppose you are here, right? Suppose you are at this ABC. So in this case, your current string S is ABC. So after you are backtracking from here, after you are backtracking from this ABC, then you want to regenerate this ABC, right? You want to get this ABC back, because after this, because you want from this ABC, you also want to go to this BAC, right? So that's why you need to restore back the original string. So that is why while you are backtracking, then since you have swapped, like currently your index was where your IND index was standing at B and your I was standing at C. So you have swapped both of them. That's why it became ABC. Then while you are backtracking from here, while you are moving back from here, so you swap the index along with the I as well here, so that you can get back to this ABC. Similarly, when you are here, so you swap what? You swap here, if you will observe. So what are the things that you swap? So if you have BAC, right? So what you swapped A and B, so you got B and A, then C, right? So here also you will swap A and B once again, so that you can restore back to ABC, such that you can get the new permutation CBA, right? So that's why I'll be doing a backtracking step, and that will be nothing but what I'll be calling the swap, and swap for the index I'll be calling, okay, and then I'll say that S of I, swap it with S of I, right? This is something that I'll be doing. So this is nothing but the backtracking, right? Backtracking process that I'm implementing it. Now I think it seems to be correct. Let's try and compile this to see if there's any other error. Okay, there is a compilation error. So it is saying st.push. Yeah, instead of push in set, I should have the insert function here, right? So I should have the insert function. Let's try and compile this to see if it can work here. Okay, so we are getting the same expected output. Let's try and submit this as well. Okay, so you can see that our solution was able to pass all the test cases. So this was the problem, and it has been asked in various companies. Thank you. In this video, we will discuss the problem add binary strings. The problem says that we have been given two binary strings A and B, and they consist of zeros and ones only. So we have to find the resultant string after adding the two binary strings. So we know that we can add numbers, right? If I was given, let's say, 87 and I was given, let's say, a number like 12, so I could add them up and they would become 99. Okay, if I add them up. But like what happens when I have binary strings? Can I add them up as well? Yes, I can add. So I know that 1 plus 1 in terms of binary is what? Is 0 here, like, because it becomes 0 and 1 gets carried. So here two zeros are there, so that's why it will be a 1. So 1 plus 1 will be nothing but 1 and 0 here in the binary addition. Apart from this, if you see, 1 plus 0 will be nothing but 1. 0 plus 0 is obviously 0, right? And 0 plus 1 is also 1. So these type of things will happen. So basically, if you see, if it's a normal addition like this, like 1 plus 0, 0 plus 0, or 0 plus 1, then you'll get the normal answers. But the thing is about the carry, as I mentioned, because if you have a string 1 and then 1, like if you have two of the characters as 1, if you add these up, add these up, then what happens? Then it becomes 0, and then you get a carry as 1. Okay, you get a carry as 1, and then you write it here. So basically, the carry concept is the main part here. Now, how can we do this particular question? So let's move to a test, some of the test cases that has been given. So let's say if we have 1 and 0, okay, and we have 0 and 1. If I add these two up, so what will happen? Like, first of all, from where will I start adding? So I will start adding from there. I will start adding from the rightmost. I'll start adding from the rightmost of both the strings, right? Both the strings. So if suppose that the length of the like, let's say that there is a string, let's say there is a string A, okay, and let's say there is another string B. So in that case, what I would be doing is I will simply say that if two strings have been given to me, I can simply say that here I will say that if the string is given like 1 0 0 1 suppose, and the another string b is like 1 1 1 1, so I need to do what? I need to, let's say it's like this 1 1 1 and 1. Okay, so what I need to do is I need to add these two characters up, right? The rightmost characters up. So if suppose my I is currently 0, so what will be these characters, right? These this the length of this word suppose is n, the length of this word suppose is m. So what will be this character, right? This character's index will be nothing but the character's index will be n minus 1. Okay, and if I do minus I, then also I'll be at this character. Then suppose after that I do an I plus plus. So if I do an I plus plus, so I becomes 1. Okay, so I will tell you about this part a little bit later on, but let's try and first of all see what will happen. So if I add these two up, right, so this becomes 1a and this becomes 1a because there was no carry. So that's perfectly fine, right? 1 and 1 is perfectly fine. But suppose if I have been given another string. So first of all, let's discuss. Let's say there is a string like 1 1 1 0 0 1, right? So first of all, I want to add this character of the string. Okay, so suppose the length of this string is n. So what is this character? This character is nothing but n minus 1. This character is nothing but n minus 2. This character is nothing but at the index n minus 3 according to the indexing in the string. So how can I get to this character? Okay, so I can say that initially I can start my I from 0. I can say that this character is nothing but n minus 1 minus I. If I increment my I, if my I moves to 1, then what will happen? This character is nothing but n minus 1 minus I, because I value is 1. Then also n minus 1 minus I, right? N minus 1 minus I. So for both the strings, it will be n minus 1 minus I, and it will be m minus 1 minus I for both the strings. First of all, now there could be a case where the characters are not present, right? Suppose what happens is, if I have been given the strings, suppose the string is like this 1 0 0, and the other string is like 1 and 1. Okay, so suppose I add these two up, so this will be 1 and 1. Now what happens when I check for this string? So for this string, this particular character is not existing. Okay, so for that, what I will do is I'll have x and y initialized as 0 initially, and x will tell me about the ith character of this, like x will be equal to a of n minus 1 minus I, and y will be equal to b of m minus 1 minus I. Okay, and if it happens that I have exhausted the length of the string, so suppose for the second string here, I can see that I have exhausted it already, then x is 0 here, so it will behave like 0, so that the addition can be performed normally, right? This will be the thing. Now let's talk about the carry part by taking in a sample test case here. So let us say if I have been given this test case like 1 1 0 and 1, and then triple 1. So if I have been given 1 1 0 and 1, and then 1 1 1. Okay, so what I will do is I will run till when? I will run until either of the strings, like I will have a while loop. Okay, so initially I is going to start from 0. I can see I'll have a while loop, and I will run until I am lesser than n or I am lesser than m, right? This is what I can see initially, that if the first string has not got exhausted, then I will be running. If the second string has not got exhausted, then also I'll be running. Okay, if either of the strings get exhausted, even then I'll be running, because for the other corresponding character, I will have a 0 for it, right? So I'm saying that I will have x is equal to 0, I'll have y is equal to 0 as well. And for this part, as you can observe, like what is happening here? If I add these two, if I add this character and this character, right? So basically, what will, like, I can see that they are existing. Is it existing? Yes, because you can see like I is lesser than what? I is lesser than n, and it happens like, and I need to initialize x to 1. So when will I initialize it to 1? So I'll say that if a of n minus 1 minus I is equal to 1, if this character is 1, then you mark your x as 1. Okay, if it's existing. Similarly, you say that what if I is lesser than m, and b of the, for the second string, m minus 1 minus I is equal to 1. Okay, so in that case you mark your y as 1 as well. Okay, so basically these two are marked as 1. So y plus x, right? Basically x plus y, it will be here. So should I write a 2 here? No, basically these are binary strings. So what should I write? So if you see the normal addition of characters, if you say that I am adding 8 plus 9, so if what will I get here? I'll get overall 17, but I write here as 7. So that is nothing but modulo 10. So here, since we are like, this was when we were talking about decimal numbers, then we modulo with 10. So if we talk about binary numbers, then we modulo with 2 here. So that means nothing but what will happen here? It will be nothing but x plus y modulo 2. But will this be the case always? Because let's try and understand. If we do this, so this becomes 0, and here it becomes 1. Okay, so now you see, right, one of the carry part is coming. So for that I need a carry variable as well. So I'll initially mark a carry as 0. Okay, you will say that, okay, why are you marking a carry as 0? Because for the very first time the carry will actually be 0. Okay, that's why. Now I will increment my I. Okay, so basically now what's going to happen? I will increment my I one by one. like I also need to update the answer. I know that, right? I will have, let's say I'll have an answer string, okay, and every time I'm adding this thing, so I'll keep on updating it as well, right? So if I have this thing, so I will say that like what will be the current that will be added. So basically if I'm trying to add, right, so it will be nothing but x plus y plus the carry part, okay, modulo 2, modulo 2 will be the part that will be get added to the current ith index. So here if I see, so that's nothing but what, 1 plus 0 plus 1 modulo 2. So I'm going to get a 0 here as well, right? That's perfectly fine. Then I'll get the carry as 1. So how will I get the carry? So carry is equal to nothing but what? Carry. If I see the current sum at this index is x plus y plus carry modulo 2, then the carry part is nothing but x plus y plus carry divided by 2, okay. So in that case you can see here actually this has become 2, so 2 divided by 2 will give me 1, so 1 gets as carry. Now you see 1 1 and 1, so 3 ones are there, so that means 1 plus 1 plus 1, so modulo 2 will give me here 1, okay, and then I'll pass on one more 1. Now you can see that I, like, till here I keeps on moving. Now for, you can see here that I is not existing here, right, at this particular index. For the second string at this particular index I is actually not existing. So if I is not existing, then actually y is already initialized as 0, so it will work here, right? It will not, the code will not get damaged, right? Or it will not get any edge case here. So what will happen here is you have a 0 here, right? So y is performing this part. Now what you will do is you have this, so carry 1 plus 0 plus carry, so I will get what here, 1, I will get 1 because I'm modulo, no, I'll get a 0 here, right? Because I'm adding 1 plus 1, so that means 2 modulo 2 will be 0. Then I'm adding one more part. Now you will say that the string has got exhausted. We have got one more carry, but the string has got exhausted. I can see that neither the first string nor the second string is length is existing because I've exhausted both the strings. But in this case I will say that, or it happens, like I will say that now iteration could be done if it happens that the carry is not equal to 0, then also the iteration can be done, okay. Because if the carry is still remaining, then I need to add them up. So in that case x and y will be initialized as 0 because this if and this if will not be running. So what will happen is 0 and 0, you can imagine, so this will be 1 and then the carry becomes 0, so now the condition will be there, okay. So that is what will happen here. Now let us see what will keep on happening. So every time what I will do is I will say that answer plus, like I can say that answer plus is equal to nothing but what, answer plus is equal to this thing, that is answer plus is equal to basically the current sum, right? That is nothing but x plus y plus carry modulo 2, right? Although I need to change this thing to string while adding it in the string, okay. And then the carry part, for the carry part I can say what, carry part will be nothing but what, carry part will be x plus y plus the carry part divided by 2, okay. So this is how it will get on adding, and then I will do an I plus plus, okay. Now what will happen next? So once this part has been done, so now my task is to like, there's one additional constraint that has been given. So let us say that I develop this answer. So what will happen? Like it will be developed something like this. Let me just move down a little bit so that we can check. So let us say I've developed this answer that is here. So this answer will be what? Like it will be 1 0 1 0 1 then 0 0. Okay. So basically, like it will be what, like 1 0 1 0 0, right? If this answer is there that I have developed, let me just check once again. So 1 0 1 0 0. Okay. So actually, if I'm doing answer plus every time, if I'm doing answer plus is equal to this thing, if I'm doing answer plus is equal to the string, and if I'm adding it from the back, if I'm adding it from the back one by one, so if I'm doing answer plus is equal to the current part, right? The current sum. So what will happen in that case? It will actually get added like this. Actually, the answer will look like this. That is 0 0 1 0 1. Okay. So then what I need to do is I need to reverse this, right? I need to reverse this in order to get it like 1 0 1 and then 0 0. Okay. So I need to reverse it. But there is one additional constraint that has been given in the problem. It says that the input strings may contain the leading zeros. Okay. So like it is saying what, like actually they will give the input strings like this. Suppose they give you 0 0 1 0 1 and they give you 0 0 then 1 1 1. So you'll add these up. But if like let's say if this was 0 0 as well, okay. So in that case, this will become what? This will become 1 0 1 and then 0 0. So now you can see here in this part that actually here you are having leading zeros, but it is saying that final answer should not contain any leading zeros. Okay. So in the answer, how will it get stored? In the answer, it will actually be stored like this: 0 1 1 and then 0 0. So you can see in the answer these are the leading zeros actually. So you will iterate through this answer string from the back side, and if the character is 0, then you will pop it out. So you'll pop this out, you'll pop this out, and then when there's no 0 left, then you will reverse this up. So it will be nothing but 1, 1 and 0, so that you can get just this part. So this was the important part. That is why this is a medium level problem, and it has been asked in various companies, right? If you will see the tags also, so it has been asked in Facebook, Microsoft, Amazon. So a lot of companies have asked it. Now let's try and implement it to see what happens. So basically what will happen is, I'll say that I is equal to 0 initially, and I'll have the x initialized as 0, let's say, and y initialized as 0, and I'll have the like y initialized to 0 as well, and I'll have the carry part as well. So carry will also be initialized to 0. Then I will say that while my I is like, first of all I need to calculate the length as well. So int n is equal to nothing but what, like let me write this as a small a and small b, as I have explained it using this concept. So like it will be what, a dot size, right? A dot size, and int m is going to be what, b dot size, the size of the second string. And then what I will be doing is, I'll be iterating through the strings one by one. So I'll say that while I is lesser than n, or I is lesser than m, or it happens that the carry part is not equal to 0, till then I'll be iterating as I mentioned. And I'll say that initially x is equal to 0, also y is equal to 0, right? After this part is done, so I need to check what I need to check. I need to check for the current strings, for the first string, if the character is 1 and it's existing, right? So if I is lesser than m, and it happens like I is lesser than m n, and it happens that what it happens that a of n minus 1 minus I, as I discussed in the example, for the characters from the back I have to add, because in a string I add the characters like in terms of addition, I first of all add the characters that are towards the right side. So if it's equal to 1, okay, in that case I mark my x as 1, okay. And similarly I check it like if I is lesser than m, and b of m minus 1 minus I is equal to 1, right? So in that case also I mark my y as 1. Now what will I do? I'll say that int the current sum will be what? Current sum will be nothing but, current sum will be the sum. So the current sum will be what? Current sum will be nothing but x plus y plus carry, okay, and I will say modulo 2, okay. And now what will be the carry? Carry will be nothing but, carry will get updated to what? Carry will be nothing but carry, uh, like carry will be nothing but what, x, like it will be, carry will be nothing but x plus y plus carry divided by 2. So it will be nothing but x plus y plus carry, then I divide it by 2 to get the carry part, because this is a binary number. Also what I need to do is, I need to say that answer plus is equal to 2 string, because currently the current sum that I've calculated is a integer, so I'm adding it into a string. So that's why I will say that 2 string current, okay. Then I'll convert it, and then I will say that I need to do I plus plus, so one by one I need to keep moving my indexes part, right? Now once this part has been done, so what is the next part left for me? So I need to check here, right? I need to check that, like I will say that int j starts from what, answer dot size minus 1. So I need to check it from the back, that if there is any character that is 0, so I need to pop them out, okay. If there are any leading zeros in the final answer, so I need to pop it out. And so that's why what I will say is that if answer of j is equal to 0, right? If it's 0, then what I will be doing is, I will say that answer dot pop back, like answer dot pop back. So basically this will do what, this will pop out the previous characters, right? This will pop out the back characters that are 0, right? So as I mentioned, if I have this example, so if I have 0 1 1 0 0 as is stored in the answer, and I don't want these starting zeros, right? If I don't want these initial zeros, so what I will do is, like I can see that in the answer it is stored like this, so I will pop this out, okay. Then my j moves to this, so I'll pop this out as well. So now my answer looks like this, and then I will reverse this answer to get 110 as the final answer, right? So that's what I'm trying to do here. So that's why I'll do a j minus minus once I'm done with this index. And after this part is done, so I can simply say that what, I will reverse the final, like I'll reverse answer dot begin, comma answer dot end. So I'll reverse this particular answer that I have developed up till now, because basically what is happening, if I have developed this answer, so I need to reverse it, right? Because I have stored it in the backward order. Now after this part has been reversed, so I can simply say what, I can simply say that I can return the answer here. Let us try and compile this to see if there is any error, or we have tried to do it correctly. Okay, so there is a compilation error here. It says that answer plus is equal to, yeah, so I have not declared the string here, so I should declare the string as well. So I should say that string answer is equal to initially null. Okay, now it should work, I think. Let's see what happens. Okay, so we are getting the same expected output. Let us try and submit this code as well. Okay, so I think it got accepted. You can see that our problem was able to pass all the test cases. Now you can see, since this problem was a important in terms of edge cases, that is why this is a medium level problem, and that is why companies have asked this problem as well. Now talking about this part, that is the time complexity of this code. So the time complexity will be like, you can see, right, in what am I trying to do? I have been given a string A, I've been given a string B, so I'm basically iterating through both the strings, right? I'm iterating through both the strings. So what will be the maximum number of iterations that I'll be doing? So the maximum number of iterations will be nothing but what? It will be nothing but maximum of n comma n, that is maximum of the size of the first string or the second string, whichever is greater, that many number of times I'll be iterating, and the space complexity will be what? Since I'm storing the final answer in a string, so that way it will be again order of maximum of nothing but n comma m, that is whichever string size is maximum, that many number of characters I'll be storing close to that in the worst case, right? So this was the problem. Thank you. Now, talking about the practice problems as well. So, I'm giving you a problem that is implement ATOI. I'm giving you a problem that is longest palindrome in a string. So, basically, in ATOI, what you have to do is you have to implement the function ATOI that takes a string as an argument and converts it into the integer and return it. Then you have to find the longest palindrome in a substring. So, you will be given a string, and you have to find the longest palindrome in the string. The third problem that I'm giving is factorial of large numbers. So basically, you'll be given a lot of you will be given a number integer n, and you have to find the factorial. Now, since integers cannot store long even cannot store the large factorials, so that is why we store it in terms of strings. So you can try this problem out as well. Thank you.